We're doing worksheet number 14, which is regular and irregular polygons. Let's quickly revise a few concepts before jumping onto the past papers question. So we have a pentagon in the figure, and these angles right here are called the interior angles. And to find the sum of the interior angles, we have a general formula which would work for any polygon, for a 5-sided polygon or for a 50-sided polygon. The formula is 180 times n minus 2. So for this particular figure, the value of n is the number of sides the polygon has. So our polygon has 5 sides. So 180 times 5 minus 2, which gives us 540, I believe. So sum of all these 5 interior angles of a pentagon is 150. Now if this were a regular polygon is when all sides of the polygon and all angles of the polygon are equal. So let's assume that these 5 sides are equal in length. This side, this side, this side, this one and this one. All 5 sides are equal in length, which means that all angles are also equal in size. So to find each angle now, we'll use this formula: 180 times n minus 2 divided by n. For this particular polygon, the value of n is 5. So we substitute 5 here. 180 times 5 minus 2 divided by 5, which gives us 540 divided by 5, which gives us 108. Yes, 108 degrees, which means now that each of these interior angles is 108. So this regular polygon will have 5 angles, each of size 108. Now let's discuss what are exterior angles. Like we just said, if this is the interior angle, this is one interior angle, and if we extend this interior angle, if we extend the baseline of the interior angle, the angle outside would be the exterior angle. This angle right here is the exterior angle, and we notice that interior angle and exterior angle both are lying on a straight line, which gives us that formula that interior angle plus exterior angle is equals to 180 degree. Next, in the previous part, we discussed that we are given the number of sides of the polygon. From this, we found each interior angle, which came out to be 108 for the pentagon. Now, sometimes the question goes other way around. You're given this value and you're asked this value. For that, we have two options. One option is simply that we substitute the formula. Each interior angle is equals to 180 times n minus 2 over n. In this case, n is 5, so 180. 5 minus 2 over, sorry, we don't know n, we need to find n. So 180 times n minus 2 divided by n, cross multiply, which gives us 180 times n is equals to 180 n minus 360. Take 360 to the other side and then subtract 180 n and 108 n. We get 72 n, and then divide 72 when it goes to the other side with 360. So 360 divided by 72, which gives us 5. So from the given each interior angle, we found the number of sides of the polygon. Another way of doing this is simply by using this formula: n is equals to 360 over exterior angle. We're given the interior angle, and remember the relationship between interior angle and exterior angle is that their sum is 180. So to find exterior angle, we'll simply do 108 plus the exterior angle is equals to 180, which gives us exterior angle is equals to 72. Now substitute the upper formula, n is equals to 360 over 72, which gives us 5. I'll be sticking to this formula from now on. Another important fact that you need to remember is that sum of all exterior angles of a polygon equals 360 degree, which means that this purple angle right here, this purple angle right here, this exterior angle, this exterior angle, this exterior angle, all these exterior angle will sum up to 360 degrees. So sum of exterior angles equals 360 degree. Alright, keep this in mind as well. Okay, some more revision before jumping on to the past paper question. Triangle has 3 sides. You need to remember these facts. It's pretty easy though. For a triangle, we know that the number of sides are 3. For a quadrilateral, it's 4. For a pentagon, it's 5. For a hexagon, remember the number of sides of a hexagon is 6. Then heptagon has 7 sides, octagon has 8, nonagon has 9, decagon is 10, and 11gon and 12gon, etc. will have just 11 and 12 and so on sides. We have to find sum of interior angle. I'm only working for the heptagon. So sum of interior angle, to find sum of interior angles, we'll simply use the formula 180 times 7 minus 2, because n in this case is 7. So 180 times 5 gives us 900 degrees. So 900 degrees is the sum of all the interior angles of the heptagon. Alright, and to find each interior angles, you simply use the formula 180 n minus 2 divided by n, which in this case will be 900 divided by 7 sides. So we'll get 900 divided by 7. So each angle will be 128.57 rounded off degrees. Okay, now we're given some interior angles, and from that we have to find number of sides. So like we did before, we're only solving for this part. The 162 degrees. Alright, so if each interior angle of a regular polygon is 162 degrees, the question says find how many sides does this polygon have. So we have a polygon of unknown number of sides. We don't know how many sides it has, and we're told that one of these interior angles is, in fact all of these interior angles is 162 degree. So we need to tell how many sides does this polygon have. So we're only going to use this formula, which is n is equals to 360 over exterior angle. So to find number of sides, we do 360 over, how do we find the exterior angle now, since we know the sum of interior angle and exterior angle is 180, and we know the interior angle, which is 162. So to find the exterior angle, simply subtract 162 from 180. So 180 minus 162, and we get 18. Divide 18 here, and we get 360 divided by 18, we get 20. So this particular polygon has 20 sides. Okay, we've now started worksheet number 14B, question number 1. Find the sum of interior angles of a 25-sided polygon. So it's a very straightforward question, very easy question. Sum of interior angles has the formula 180 times n minus 2. The polygon has 25 sides, so n is 25 minus 2, and this will give us 4140 degrees. This is question number 1. For question number 2, the Pentagon has 3 angles which are each 140 degree. The other 2 interior angles are equal. Calculate the size of one of these angles. So basically, if this angle is x and this angle is x, we need to find value of x. We're told both these angles are equal. So sum of all these 5 angles would be 180 times 5 minus 2, which is the formula for the sum of interior angle. So 180 times 3 is 540. Now 540 will be equals to all these 5 angles. So we're given 3 of the angles which are equal to 140, plus we have 2 missing angles of the same size. Now we'll simply apply algebra. 540 minus 3 times 140 is 420 is equals to 2x. Subtract these, divided, we get 120, then we divide it with 2, we get 60. So the answer for the angle is simply 60. Question number 3. Five angles of a hexagon are 115 degree. Calculate the size of the 6th angle. Hexagon has 6 sides. They've also given you the hint by saying calculate the 6th angle. So obviously hexagon needs to have 6 sides to have 6 angle. So sum of all the 6 angles of the hexagon would be 180 times 6 minus 2, which gives us 180 times 4, which is 720. And of these 6 angles, we know that 5 of the angles equals 115, and we have a missing angle. So use algebra to solve this. 720 minus 5 times 115, which gives us 145. So x is equals to 145 in question number 3. Question number 4. The front of a house is in the shape of a hexagon with 2 right angles. The other 4 angles are all the same size, which means that this angle, this interior angle, this interior angle, this interior angle, they're all of the same size. So let's call all of them x. Calculate the size of one of these angles. So simply for question number 4, first we need to find the sum of all the 6 angles. We have a formula for that, 180 times n minus 2. N in this case is 6 because hexagon has 6 sides. This gives us 180 times 4, which is 720. So 720 will be equals to 2 angles of 90 degree plus 4 angles of size x. Let's subtract these. 720 minus 2 times 90, which gives us 540, and then we divide it with 4, and we get 135 degrees, which is the answer. Question number 5. The diagram shows an octagon. So n is equals to 8 in this question. All of the sides are the same length. 4 of the interior angles are each 32. So this will also be 32 degrees. This will be 32 and this will be 32. The other 4 interior angles are equal. Find the value of x. Now, if this angle is x, then this whole angle will be 360 degree. So the remaining angle would simply be, this angle would be 360 minus x. Same will be this angle, and this angle. So we have 4 angles of size 32 degrees and another 4 angle of size 360 minus x degrees. And the sum of all these 8 angles can be found by using the formula 180 times n minus 2. N is 8, since this is an octagon. This will give us 180 times 6, which is 1080. We're doing question number 5. So 1080 is equals to 4 angles of 32 degrees plus another 4 angles of 360 minus x. We need to find the value of x, so let's apply algebra here. This is 1080 is equals to 4 times 32 is 128 plus 4 times 360 is 1440 minus 4x. Let's take minus 4x to the other side and add 128 plus 1440 and then subtract 1080 from that. We get 488. Divide 4 here and we get 122 degrees, which is the value of x. Question number 6. A regular polygon has interior angles of 176 degrees. So a regular polygon has interior angles of 176 degree. Find the number of sides. So to find the number of sides, we'll use this formula. N is equals to 360 over exterior angle. Now if interior angle is 176, then exterior angle will be simply 180 minus 176, which gives us 4 degrees. So we write 4 here and then we get 90 degrees. Answer. Question number 7 is exactly the same as question number 6. Now the interior angle is 172 degrees. So n is equals to 360 over exterior angle. Exterior angle would be 180 minus 172, which gives us 8. So divide it with 8 and we get 360 divided by 8, we get 45 degrees. Question number 8. A regular polygon has an exterior angle of 40 degree. Work out the number of sides of this polygon. So simply formula is n is equals to 360 over exterior angle. N is equals to 360 over 40 in this case, which gives us 9. For question number 9, simply the value of the denominator has changed. So n is equals to 360 over exterior angle now is 24 and the answer is 15. For question number 10, it's almost similar to the previous two questions. The exterior angle of a regular polygon is 36 degree. What is the name of the polygon? Now from the number of sides you have to determine the name of the polygon. So n will be 360 over exterior angle, which is 36. This gives us 10. So what is the name of a polygon that has 10 sides? It's decagon. So the answer is simply decagon. This will get you the marks, not just writing the value 10. Question number 11. A A regular polygon has n sides, each exterior angle is 5 n over 2 degrees. Find the value of n. So we have a formula connecting n and each exterior angle, which is n is equals to 360 over the size of the exterior angle. Now n will stay n, 360 over the size of the exterior angle is 5n over 2. Now let's apply algebra. 5n over 2 will go to the other side, get multiplied with n, so we'll get 5 over 2 n square is equals to 360. Take 2 to the other side, it will get multiplied with 360 and divided with 5. So 360 times 2 divided by 5 gives us 114, and this was n square. Now to get rid of the square, we have to take under root on both sides, so we get n is equals to under root 114 is 3, I think this was 144, not 114. Let me recheck. 360 times 2 divided by 5 is, yes, 144. Now take under root of 144, which gives us 12. So the answer for the number of sides is 12. Usually in such questions we first write plus minus 12, but since we're talking about number of sides in a polygon can't be negative. So we completely ignore the negative sign and just take the positive sign. Question 12 is pretty much same as the previous questions. Question number 12. The diagram shows two of the exterior angles of a regular polygon with n sides. Calculate n. N is simply 360 over size of the exterior angle, which is 6 in this case. So the answer is 60. This polygon has 60 sides. Question number 13. Calculate the size of one interior angle of a regular 12-sided polygon. So we know the formula for each interior angle in a regular polygon is equals to 180 times n minus 2. So in this particular case, n is 12, so 180 into 12 minus 2, and divided with n as well. So n is 12 divided with 12. So we have 180 times 10 divided by 12, and we get 150. Question number 14. Find the interior angle of a regular polygon with 18 sides. So interior angle means each interior angle. So again use the same formula, 180 times n minus 2, n is 18 in this case, divided by 18 again, which should give us 160 degrees. Question number 15. A regular polygon has 72 sides. So we know the value of n is 72. Find the size of an interior angle. So again, to find interior angle, we have the formula 180 times n minus 2, n is 72, minus 2 over the number of sides, which is again 72. This should give us the answer, which gives us 175. Question number 16. Show that each interior angle of a regular pentagon is 108. So for a pentagon, n is 5. So 5 minus 2 divided by 5 is equals to 108. So we've shown what the question asked for. Right. Question number 17. The diagram shows a regular pentagon. AB is a line of symmetry. Work out the size of D. So it's a regular polygon, so we can find each interior angle. We can find the value of all of this angle, this angle, this angle, this angle. They'll all be the same, and we'll find that by using the formula 180 times 5 minus 2 divided by 5, which will give us 108 degrees. Now all of these angles are of size 108 degree, and since line AB is the line of symmetry, it will divide the angle D in two equal parts. It will divide the angle A, this whole angle, which was of the size 108, into two equal parts. So to find D, we'll simply do 108 divided by 2, which gives us 54 degrees. Question number 18. The diagram shows a part of a regular polygon. The exterior angle is x degrees, the interior angle is 29x degrees. Work out the number of sides of the polygon. So first we need to find the value of x, and we know the relationship between interior angle and exterior angle, that they sum up to 180 degrees. Interior angle and exterior angle sum up to 180 degrees. So exterior angle is x, interior angle is 29x. They sum up to 180. Add these, we get 30x. Divide 180 divided by 30, and we get 6. And then now we know that the size of this angle is 6, which is the exterior angle. To find n, we use the formula 360 over exterior angle. So 360 over 6 gives us 60. So this polygon has 60 sides. Alright, next question, question number 19. The exterior angle of a regular polygon is x, and the interior angle is 8x. Calculate the number of sides of the polygon. So it's exactly like this question, but the figure is not given. So just know the relationship between interior angle and exterior angle is that they sum up to 180 degrees. So x plus 8x sum up to 180. We get 9x here. X equals to 180 over 9. 180 divided by 9, which gives us 20. So to find n, we'll simply do 360 over exterior angle, and exterior angle is 20. So the answer is 18. Question number 20. Interior angle of a regular polygon is 8 times as large as the exterior angle. So if the exterior angle is x, then the interior angle will be 8x. It's actually the same as this question with a little change in wording. One question is from May-June 2018 paper, and the other one is May-June 2010. Alright, but they're exactly the same, only the wording is a little different. So interior angle of a regular polygon is 8 times the exterior angle. So let's find the exterior angle first, which is the value of x. They sum up to 180. So like in the previous case, x will come out to be 20, and then just like in the previous case, to find n, we do 360 over exterior angle, 360 over 20, which will give the value 18. Question number 21. In a regular polygon, the interior angle is 11 times the exterior angle. So let's say if exterior angle is x, then the interior angle will be 11x. Part 1, work out the number of sides of the polygon. So again, the sum of interior angle and exterior angle is 180. So x will be 180 divided by 12, which gives us 15. So 15 is the size of the exterior angle. To find n, we'll use the formula 360 over exterior angle. which is 15. So 360 divided by 15 gives us 24. Part 2. Find the sum of interior angle of this polygon. The formula for that is 180 times n minus 2. N is 24 like established in the last part. So 180 times 22 will give us 3960. Question 21. Sorry, question 22. The diagram shows two regular pentagons. The outer pentagon is an enlargement of the inner pentagon with center O. Find the angle AEK. So we need to find this marked angle. Notice this angle will be equals to this angle. They're both equal. And then we can easily find this inner angle by finding each interior angle of a polygon. So in fact this is a pentagon, so we can find each interior angle of the pentagon, which will give us the green angle, and then we know that this angle and this angle, they're equal. So we'll sum up all these three angles and the answer should be 360, because sum of angles originating from a point equals 360 degree. So let's find each interior angle of a polygon first, of a pentagon. So we know the formula for that is 180 times n minus 2 divided by n. So n for a pentagon is 5, it has 5 sides, so 180 times 5 minus 2 divided by 5, which gives us 108. Let me double check. 180 times 3 divided by 5, yes, 108. So I know x plus 108 equals 360 degrees. So subtract 360 minus 108, and then we get 252, and then we divide it with 2. 252 x is equals to 252 divided by 2, 126 degrees is the answer. Question number 23. The diagram shows a regular octagon joined to an equilateral triangle. Work out the value of x. What is an equilateral triangle? It has 3 equal sides and also 3 equal angles, which are each of size 60 degree. So this angle is 60 degrees, this angle is 60 degrees, and this angle is 60 degrees, because it's an equilateral triangle which has 3 equal sides and 3 equal angles. Next, if we find this angle, we can simply do this green angle plus x plus 60 would sum up to 360, because angles originating from a point equals 360 degree. And how do we find the green angle? It's actually the each interior angle of a regular octagon. So we have a formula for that. Each interior angle of an octagon can be found by 180 times n minus 2 divided by n. N for octagon is 8, so 180 times 8 minus 2 divided by 8. This will give us 180 times 6 divided by 8, 135. So this angle is 135, so we'll do 135 plus 60 plus x equals 360. So to find x, subtract these two from 360. 360 minus 135 minus 60, which gives us 165, which is the final answer. Question number 24. The vertices A, B, C, D and E of a regular pentagon lie on a circumference of a circle. Its center is O and radius 7 centimeter. They also lie on the sides of a rectangle WXYZ. Show that part 1, angle DOC is equals to 72 degrees. So we need to show that this angle equals to 72 degrees. So all we need to do is join these lines and notice we are getting 1, 2, 3, 4, 5 equal angles. And what's the size of an angle what's the sum of angles originating from a point? That is 360. So simply do 360 divided by 5 and we'll get 72 hopefully. Yes, 72 degrees. So this is part 1. Part 2, angle DCB equals, show that angle DCB equals 108. So where is DCB? Here it is. So we need to show this angle equals 108. This is the interior angle of the regular polygon. We have a formula for that, 180 times n minus 2, n is 5 here, divided by n, which is 5, which gives us 108 degrees. Part 3, find angle CBY should be equals to 18. So CBY, we need this angle. So in this triangle, this angle will be equals to 90 degrees because it's a rectangle. It's given in the question that WXYZ is a rectangle. So all of its interior angles equals 90 degrees. So we have the red angle, so from that we can find this angle by subtracting it from 180. So let's find this purple angle first. I'm calling this angle BCY. This is equals 180 minus 108, which is 72. Next we'll do 72 plus x plus 90 equals 180. So 180 minus 72 minus 90 is 18. So x equals 18, and we've shown that. Question number 25. The pentagon ABCDE, where angle EAB and angle ABC are 110 and angle CDE is 84, and these angles equals to x. Calculate the value of x. So we know that the sum of all these 5 angles should be equals to sum of interior angles of a pentagon, which is 180 times 5 minus 2. This gives us 540. So 540 equals 84 plus 2x plus 2 times 110. Now keep 2x over here and move the rest. So 540 minus 84 minus 2 times 110. We get 236 is equals to 2x, and then x is equals to 118. This is part 1. Part 2, BC is equals to CD. So these two lengths are equal. Calculate angle BCD. So we need this angle, B to C to D. Sorry, CBD. So we need this angle. We'll have to draw this line, and we need this angle. So it's an isosceles triangle. So if it's an isosceles triangle, it means its two sides are equal and two angles are equal as well. So this angle also will be equal the same size. So let's call both of these y. Now x plus 2y equals 180 and x is 118 plus 2y is equals to 180. Solve this. 180 minus 118 divided by 2, and we get 180 minus 118 divided by 2, we get 31. So 31 is the answer. Part 3 of question 25. So this pentagon also has one line of symmetry. So its line of symmetry will be this line here. So this pentagon has one line of symmetry. Line of symmetry is the line which cuts the figure into two overlapping parts. So the blue line is the line of symmetry. Calculate the angle ADB. So for that we need to make an extra line, connect A and D. So we need this angle over here. So all of that angle was 84 in the background. This whole angle is 84, and since this figure has a line of symmetry, then this is also y, and we know the value of y, which is 31. So we can write 2 times 31 plus the green angle is x, which we need to find, equals 84. So x equals 84 minus 2 times of 31, which gives us 22. Question number 26. One angle of an isosceles triangle is 48 degrees. Write down two possible pairs of values of the remaining two angles. So if one angle is 48, and this is what the isosceles triangle look like, this angle might be equals to 48, or this angle might be equals to 48, or maybe this one, but these two are the same cases. Alright, so if the upper angle is 48 in the first case, then we should know that these two angles will be equal. This will be x and this will be x as well. So 48 plus x equals 180, and 2x equals 180 minus 48, which gives us 132. X is equals to 132 divided by 2 is 66. So both those angles are 66. So one possible option is 66, and 66 is the size of the two remaining angles. Let's move to the other figure. Now if this angle is 48, then this angle is 48 as well. Now to find this angle, we'll simply do 180 minus 2 times 48, which will give us 84. So now the two possible answers are 48 and 84. Part B. Calculate the sum of interior angle of a pentagon. So it's pretty straightforward. Part B here. This was part A, which is 180 minus 5 minus 2, which gives us 180 times 3, which gives us 540. Part C. Calculate the sum of the angles A, B, C, D, E, F, G. Now remember, in the start of this lesson we discussed that sum of all exterior angle equals 360 degree, and we know that if we extend this vertical line, we just extend the straight line, this is the interior angle, then this is the exterior angle, right? Similarly, extend this line and this will be the exterior angle. Extend the line and this will be the exterior angle. Extend the line and this will be the exterior angle for the upper polygon, and this will be the exterior angle for the upper polygon as well. And also we know that the sum of angle on a straight line equals 180. So this is 180, this is 180. And for the lower quadrilateral, let's do some more extending. So if we extend it like this, this is the exterior angle. Extend it again, and this would be the exterior angle, and for the upper portion this will be the exterior angle and this will be the exterior angle. And we have two angles of size 180 degrees over here as well. So this covers all the alphabets A, B, C, D, E, F, G. So what is the sum of all of these angles? We have how many angles of size 180, how many red lines, 1, 2, 3, 4, 5. So 5 times 180 plus sum of exterior angle for the upper polygon will be 360 and sum of exterior angle for the lower polygon will be another 360. So let's find this value. 5 times 180 plus 360 plus 360, which gives us 1620. Question number 27. A, B, C, D, E, F is a hexagon. Now how many sides does a hexagon have? 6 sides. The interior angle B is 4 degrees greater than interior angle A. So we have an interior angle A, let's say it's x degrees. Then interior angle B is 4 degrees bigger than this. Interior angle C is 4 degrees bigger than B. So C will be x plus, if it's 4 bigger than this, that means it's actually 8 bigger than this. So plus 8, and so on with each of the next interior angle 4 degrees greater than the previous one. By how many degrees is the interior angle F greater than A? So we're simply adding 4 to each previous angle. So A, B, C, D, E, F. This will be x plus 8 plus 4, 12. Then we have x plus 16. Then we have x plus 20. So let's reread this question. By how many degrees is interior angle F greater than interior angle A? So this was x and this is x plus 20. So the answer is it's 20 degrees bigger. So 20 degrees is the answer for part 1. Part 2, calculate the interior angle A, which means we need to find the value of x. Now for a hexagon, the sum of all of its 6 angles will be found by the formula 180 times n minus 2, n in this case is 6, 6 minus 2, which gives us 180 times 4, which is 720. And 720 equals x plus 4 plus x plus 8 plus x plus 12 plus x plus 16 plus x plus 20. This is plus 16. Alright, so we have 720 is equals to how many x? 1, 2, 3, 4, 5, 6. 6x plus 4 plus 8 plus 12 plus 16 plus 20, which gives us 60. 720 minus 60 divided by 6 gives us 110. So x equals 110. Question number 28. Write down part A says complete the table. So for 5-sided figure, the name of the polygon is Pentagon. For an 8-sided figure, the name of the polygon is Octagon. And here the number of diagonals is 0. Then notice 2 is increasing. Then 3. Then 4. Then 5. So the next jump will be 6, which makes this 20. So 0 plus 2 is 2, then 2 plus 3 is 5, 5 plus 4 is 9, and so on. So we get 20 over here. So we filled up the table. Part 1, write down the total number of diagonals in a decagon. So let's write 9 over here and then 10 over here. So next we'll jump plus 8, add plus 8, and for the next jump we'll add 10. So to 20 add 18. So we get 38. Sorry, we add 7 and 8 here instead of 8 and 10. So we add 7 here, and next we add 8 here to get to a decagon. So that will give us 35. So the answer for part 1 is 35. Answer for B1 is 35. Next, for B2, we need the total number of diagonals for a 12-sided polygon. So again, to 35 we'll add 9 and then we'll add 10. So 35 plus 9 plus 10 will give us 54. Part C. A polygon with n sides has a total of 1 over p n times n minus q diagonals. So they've given us a general formula for the number of diagonals where p and q are integers. Find the value of p and q. So the easiest way to go about is that when n is equals to 3, number of diagonals is 0. So let's substitute that in the equation. 1 over p, n is 3, and then 3 minus q, the number of diagonals is 0. So now when we'll solve this, p will multiplied with 0, it will become 0, 3 will get divided with 0, we'll get 0, we'll be left with 3 minus q is equals to 0, which gives 3 is equals to q. So the value for q is 3. Next, we know that when n is 4, the number of sides is 4, the number of diagonals are 2. So let's substitute this. 1 over p, 4, 4 minus q is now 3 is equals to 2. Let's solve this. This is 1 over 4 p, 4, 1 is equals to 2. So 1 over p is equals to 1 over 2 cross multiply, and we get p is equals to 2. So this is the answer for C part 1. Okay, now C2. Find the total number of diagonals in a polygon with 100 sides. So we have the formula 1 over p, which is 2, and then n minus q, which came out to be 3, equals 100. Find the total number of diagonals in the polygon which has 100 sides. Sorry, n is supposed to be 100. So here half times 100 times 100 minus 3, this gives 4850, which is the answer for part 2. C3, find the number of sides of polygon which has a total 170 diagonals. So for that we'll do half n times n minus 3 is equals to 170. So this becomes n square minus 3n, take 2 to the other side, 170 times 2 is 340. N square minus 3n minus 340 is equals to 0. This will require a middle term breaking. So we need two numbers which when multiplied together should give minus 340, when added together should give minus 3n. So those numbers would be minus 20 times 17. So n square minus 20n plus 17n minus 340 is equals to 0. N is common, n minus 20 plus 17 n minus 20 is equals to 0. N is equals to 20 and n is equals to minus 17. Number of sides can't be negative, so we'll ignore this, and this is the answer. Part D. A polygon with n plus 1 sides has 30 more diagonals than a polygon with n sides. Find n. So it's actually a pretty easy question, that's why it's for 1 mark. It looks a little complex, but if you read it again and again, you'll understand what it's actually asking for. So let's see. While a 3-sided polygon has 0 diagonals, then a 4-sided polygon has 2 diagonals. So we've added 2 diagonals over here. Then by going from 4 to 5, we add another 3 diagonals over here. Then from going to 5 to 6, we're adding 4 diagonals. Actually, I'm just writing these values here. And then we needed to add 5 diagonals, then 6 diagonals, and so on. So the question is, where do we add 30 diagonals? What is the value here when we add 30 diagonals, right? Let's read the question again. A polygon with n plus 1 sides has 30 more diagonals than a polygon with n sides. So this is n and then n plus 1. They have a difference of 30 diagonals. What is the value of n? Now notice here, when we're adding 2 diagonals, the value over here is 3, 2 plus 1. When we're adding 3 diagonals, the value over here is 4, 3 plus 1. When we're adding 4 diagonals, the value here is 5, 4 plus 1. So when we're adding 30 diagonals, the value of n here should be 30 plus 1, which is 31, which is the final answer. That's all.